Okay, welcome back, you guys. And so we are going to start with the word problems. And again, we're going to take one more break after we do number 4 on the next page. Okay, let's go see what it is in context. And let's just read it out loud. Bob purchased a brand new car recently, which I need to do. When he bought the car, the odometer indicated that the car had already been driven 50 miles. The odometer on your dashboard should sort of kind of look like this. It's some sort of numerical system that you guys can see on the driver's dashboard on their side. And then every time you've driven a mile, or if you bought a car here, kilometer, then it will just keep going up. So now this will become 0 and this will become 80. So 43,580 miles. And then every single mile you keep driving, then it will be 81, 82, 83, like that. So that's an odometer. Okay, anyway. So this odometer indicated that the car had already been driven 50 miles, okay, from previous customers who did a test drive of the vehicle. Okay, nice. According to the driver's manual, the car should be able to travel a certain number of miles per gallon of gas. You'll find out that number. So miles per gallon, you guys could go like this, miles per gallon, or I think back in the States, they use the abbreviations MPG. Okay, so MPG. I don't think there's gallons over here. Korea and the rest of the world uses liters, I believe, right? I think it's liters, yeah. So funny history. I think we're one of the only 3 countries that has like something else. We have what's called the imperial system. And then every other country uses what? Metric system. A little bit different, you know? Okay. Okay. When he drove his car from the car dealership, he had a full tank of gas. Okay, that's nice. Since the car's odometer tells us the distance the car has traveled, let's use the function d of g to represent the number of miles shown on the car's odometer, number of miles, after the car has used g gallons of gas. Okay, our focus today is units because a lot of students, especially with the word problems, we tend to forget measurement. So really focus on measurement today because that's going to help you guys out with how to solve the problem, how to give a problem a unit. Okay. Because now these numbers are not arbitrary anymore. They have some sort of value. 20 gallons, 20 miles. Those are 2 different things. Okay. So G is gallons of gas and D of G is miles. Okay. Let's move on to the next page, you guys. Let's move on. Number 2, use the data from the table of values I created, to determine the slope of this function. So again, the questions are going to come back. So we got some background of this. And then what does the slope mean in context? So we'll answer 2 of those different questions on this side here. I'm going to try to color code the best of my ability. Then that way you guys can see where everything's at. I'm going to make this lime green. You guys can see this. And then I'm going to make this one pink. You guys don't have to color code. It's just for teaching purposes only. Okay. I know some of you guys are still used to having X's and Y's. So if you kind of need that calibration, go ahead and please put that. In your science classes, your X was your independent variable, the things that you guys are going to measure. Your Y's are your dependent variables because it depends on what your X's are. Okay. Take a look at our units again one more time. Your X's, your G's are gallons. And your Y's, your D of G's are miles. So we're only comparing gallons and miles for this word problem. Let's answer part 1 of this. Determine the slope of the function. Well, we already got the slope formula. So let's go ahead and use this. y2 minus y1 over x2 minus x1. Okay. One of the questions students ask me is, Mr. Lucas, there's a lot of X's and there's a lot of Y's. How do you know which one to choose? Because I made this as a linear function, you guys can choose any pair that you want. So what A1 did was they chose this as their X1 and Y1. That's totally fine. Okay, X1, Y1. And then your second coordinate over here on the table can be your x2, y2. So those are acceptable. But Mr. Lucas, can you have picked this row for your x1, y1 and this row for your x2, y2? What would be the answer? Yes, it will. Okay. You could even mix and match. This could be your x1, y1. This could be your x2, y2. Okay. So just pick two pairs of corner points. It will be okay. Okay. Just be careful now with the labeling, because some students, when they do y2 minus y1, they do it like this. 80 minus 1 over 50 minus 0. That's incorrect. Just be careful, because your y's are going this way up and down. So you tell me what to write. Go for it. Go. What's the top? 80 minus 50. So please be careful on how to read this. All over 1 minus 0. Okay? So just be careful of the reading. I usually see that happening. All right. This calculation shouldn't be too bad. This is 30 over 1. And then your slope is going to equal to 30. So let's go box that or circle that for a little bit. But we still got to answer this question over here on the side. As on the previous courses, the previous classes, we just kind of left it like 30. Now it has a unit associated with this. So now it's going to ask, what does this mean? What does this 30 mean? And I can show you to it right now. I'm going to change it back into a fraction because each of these numbers have a unit. I want to ask you first, on your y values, what is the unit of measurement? Is it gallons or miles? Miles, yes, in pink. So I'm going to put miles over here so that I know. And then what is your unit of measure for your x's? Gallons in green. So I'm going to put gallons over here. Again, the point of this is, yes, I know how to I know where you guys know how to calculate, but I just want you guys to really focus on the units today. That means that this is not 30 gallons per mile. This is 30 miles for every 1 gallon. Okay? Miles, gallon. I only need one sentence from you. This means that the car can travel 30 miles per gallon. One sentence only. Please do not give me an intro, body, and conclusion. One sentence. So your slope is a rate. It is something over something. When you guys use, one last thing before we move on to number 3, when you guys use the word per, it means already 1. Okay, so you don't have to write per 1 gallon. It's already implied that for every 1 gallon, the car can travel 30 miles. So you don't have to put per 1 gallon. Okay. If you do, I won't mark it wrong. It's totally fine. Okay. You guys, any questions on number 2? Any questions? Let us get the coordinates of the y-intercept right here. And let's just start with f of x equals mx plus b. Let's start off with that first. But we're going to have to change it a little bit. What I mean by changing is our variables are not f of x and x. Our variables are g and d of g. So we're just going to change its name a little bit, but the structure is still going to be the same. So it's going to be d of g. D of g is equal to m times g plus b. We just got to change it up a little bit. Students, what was the m that we saw for like 5 minutes ago? 30. Let's put that in. Okay. Anyone. Pick an x value. That's anyone. 2. I heard 2 first. Be careful. Where are we going to plug in the 2? The d of g or the g? The g. Very good. Which is your x. Okay. Since we heard 2 first, what has got to be your d of g or your y value? 110. You cannot pick and choose. It has to be 110. So 110 goes over here. Again, you could have also picked the other 3 coordinates and it will come out the same. All right, let's go solve for b. 110 is equal to 60, I believe, plus b. Last step, please. Minus 60 on both sides, thank you. B is equal to 50. And let's write that in coordinate form, 0, 50. There are 2 ways what we can write about in context for the y-intercept. But again, I want to focus on the units for right now. So, again, when we do coordinates, this is your x and this is your y. What was your x or your g unit of measure again? Was it miles or gallons? Gallons over here. And then 50 what? 50 miles. So I'm going to show you 2 possibilities of interpretation, and either one will be okay. The first one will sound a little bit weird, but I think the second one might be a little bit better. So here's the first one. At 0 gallons, the car had been driven 50 miles, and I'll be okay with that, because that's what it technically is. Here is an alternative to this at the beginning. Hope I spelled beginning correct. It's with 2 N's, right? Beginning? Yeah. Okay. Or another, and I think it might be a better interpretation, at the beginning, because remember, Bob is trying to buy this car. The car had been driven 50 miles. Wait, how is that possible if the car had been driven already 50 miles? Yes, because on our previous information, when he bought the car, the odometer indicated that the car had already been driven 50 miles because of the test drive. So now it's been matching up. All the calculations have been matching up to this specific word problem. Okay, so it was because of the test drive that the car had already had 50 miles on the odometer. Okay, we're going to do number 4, and then we'll take another 2-minute mental health break. You guys, any questions so far on the interpretations and context with the problem? Create the symbolic representation of this data using g and d of g. Well, first, let's write it in x and f of x, and then we're going to change some of these things. What was the slope again? 30x. And what was the y-intercept again? Plus 50. But those are not the variables. And so, this will be it. D of g is equal to 30g plus 50. So we just changed the variables because those are the variables that we have to use. D of g and g. So hopefully you guys can see that it's just a replacement of the name.